All right, well, welcome back. We have another video that's going to discuss one or two more of the physical properties of minerals. And just as a reminder, before we get started and we introduce ourselves, it's really important to start to recognize which physical properties are good for identifying which minerals, because each mineral has one or two characteristic properties that make it really easy to identify. So if we can figure out what those properties are, it's very easy to identify the mineral, and we don't have to go through and do all the properties for all the minerals. So we'll talk about that a little bit. But first we need to know who's here today. So,
I'm Jasmine.
Richie, Mr. Baldwin's class.
Ashit, Mr. Baldwin's class.
Jethro, Mr. Baldwin's class.
Great. Thanks for joining me, guys. So today we're going to talk about fracture, and we're going to talk about mineral cleavage. All right? The first one that we're going to talk about is we're going to talk about fracture. And what we're looking at is we're looking at when a mineral breaks, how does it break? Does it break in a regular pattern that we can identify? Or does it just kind of break into something that's very random in shape? So we're going to spend time looking at the shape of the mineral crystals that we can see. Now, it's really important to recognize that some minerals that we have in lab are not really excellent quality specimens. They're not the kinds of things that you would go see if you went to the Smithsonian Institution or if you went to somebody's collection that collects minerals. So there's a difference between lab specimens that we're going to work with and some of the other specimens that are like more perfect. They were grown under more perfect conditions. So let's take a look at what we have here on the table and pick out, each one of you guys maybe pick out one mineral that you think looks like it was really formed perfectly. What do you think?
Yes.
Yeah?
That one too.
No.
Is there another one?
That one looks.
Yeah, take your time.
This one?
Yeah? You like that one too?
Yeah.
Okay, what is it about those that makes you think that those are really perfect minerals?
The smoothness.
And looks like a perfect rectangle. So.
Okay.
Yeah, it's cut.
Yeah, that's good.
Ah,
It's perfect symmetry.
that's a good thing to say. So were these minerals cut, or did they grow this way in the earth?
They were cut.
They were good.
No.
They're not perfect.
They actually grew that way in the earth. They grew under really ideal conditions. They took a long time to grow, but the conditions were just perfect for them to form exactly according to the structures that they should form based on the chemical composition. So we have perfect cubes for some of these, and we have this perfect octahedron.
How long do you think this took to grow?
I don't know. It could be millions and millions of years. A really long time. Okay? So those are minerals that we're going to talk about in terms of their cleavage. Now let's pick some that we think look really random in terms of their shape. They don't seem to have any particular form. That would have
Oh, what the?
Yeah, two.
Okay. So this one looks more random than this, and yet these are the same mineral. So this one we're going to talk about fracture. This one we'll talk about cleavage. You have another one over here. Really random. Do you see any straight sides on there? Flat faces?
No.
No, right?
No.
It looks like you could just take a hammer and hit it, and it might break into a lot of pieces, but they would all be very random. Okay? And that's really what fracture is. Fracture is when you break a mineral, or when a mineral breaks, it doesn't have any regular repeating pattern that it breaks into. It's random. Okay? So that's one definition that we need to know. Fracture. Random breakage patterns. No real perfect flat straight sides. So flat straight sides here, flat straight sides here, flat straight sides here. On these minerals, those are not fracture, but these are fracture. Okay, what about that one? What do you think? Does that look random or does that look regular? You see flat sides.
On the bottom, I see.
It's
Yeah, you kind of. Inside. It's kind of. I don't know.
Is it kind of flat or is it really flat and smooth?
It's kind of.
Kind of.
Okay.
Bumpy.
So that's still fracture.
Okay.
All right, and that's a good thing to remember. Even in some of the smaller specimens, like, how about this one?
Yeah, there's a lot of bumpiness.
A lot of bumpiness to the sides, right?
Yeah.
So that would be considered fracture as well. Okay. Let's move on and let's talk about cleavage. So here we have the definition of cleavage. Cleavage is the tendency of a mineral to break along planes of weakness in the bonding structure. So we could talk about the crystal structure, the internal arrangement of all the atoms if we wanted to. And what we would find out is that atoms are arranged in a pattern where there are some weaknesses. And the way that they're weak shows up in the cleavage, shows up where they break. So for example, with these particular minerals, these two, I could take these and I don't want to destroy this one, but I could peel off very thin layers. I could take this and I could peel off layers of this. Okay? They're sheets, right? They're very thin and they're very flaky. So grab that one and see if you can do the same thing with that. See if you can peel off a layer. Get your fingernail under there. All right, there you go. You know what you just did?
Yeah, just peeled it off.
You just broke a bunch of bonds. And it broke just the way this black version of that same mineral broke, along that same plane of weakness. So here you can see the weakness, the weak plane is this way. The weak plane here is this way. That's why you can peel them off. Okay? We need to talk about the numbers of directions of cleavage, because that's how we identify cleavage. So in these two, this one and this one, these are almost the same mineral. They're in the same family. They're what we call a sheet structure, and they have one direction of cleavage. One plane that is weak. All right? And the way to identify that, whether it's a big piece like this, or whether it's a really small little flake like this, is to take your fingers and see if you can find those perfectly flat faces. So pick this up, find those two perfectly flat faces, the top and the bottom. You guys can grab those, grab a little piece of it, or grab one of the big ones. Hold it between your index finger and your thumb. The top and the bottom. Are those two perfectly flat faces parallel to each other?
Yes.
Yeah.
Yeah.
Yeah? Okay, so what you're looking at here is you're looking at a structure. The internal arrangement of the atoms is lots and lots of sheets, just like a stack of sheets of paper. And it doesn't really matter whether you're looking at the top sheet or the 50th sheet or the 10,000th sheet. You're always going to be able to stick it between your two fingers, and that's one direction of cleavage. Okay? So one direction of cleavage here, one direction of cleavage here. You see the single one direction of cleavage on each of these little itty-bitty flakes. And you could keep peeling those off into really, really fine sheets until you got down to the point where you have one layer of atoms thick. Okay? You could do that. So that's one direction of cleavage. What do you think two directions of cleavage would be if that's one? Kind of tough question. All right, let's take a look at this one. And why don't you pick it up, one of you, and see if you can find parallel sets of faces.
Would be this top and right here.
Okay, so you got a top and a bottom.
Sides. Ooh, the sides also?
Okay, so show me. Use both hands and show me top and bottom and maybe.
Oh, it's like this.
Perfect. All right, so you've got the top and the bottom and the front and the back, right?
Yeah.
Two sets of parallel faces. If we took a hammer and we hit that mineral with a hammer, it would break into smaller chunks that all have two directions of cleavage. What about the ends on that one? What about this end here and this end here? Take a look at those and see if they look the same or if they look different in any way to the other faces that you said were parallel. You might, go ahead.
Looks different because like one is like smooth, and the other one's like kind of bumpy.
Okay. Remember in the last video we were talking about luster, the way light is reflected from the surface of the mineral? look at the ends and see if it has the same luster on the ends as it does on the cleavage faces.
It doesn't.
It doesn't? How is it different?
Because the parallel sides are all a little bit more shiny, and then the other two sides are not.
Okay, so the parallel sides would be non-metallic and glassy, okay? And the ends are a little bit more towards the waxy or the dull side. So that's another way you can tell that has two directions of cleavage. Okay? All right, 3 directions of cleavage. So we're going to look at something like this. We've got these nice wooden models that we can look at, and something like this. So grab those. Whoops, we don't want to look at that one. It's got funny ends. Grab that one, and why don't you guys take one of those and see if you can identify the 3 directions of cleavage there.
There's 1, 2, and then 3.
No. 1, 2. No, 1, 2, 3.
Perfect. So do it again. You got
1.
the top and the bottom,
2.
the 2 sides,
3.
and the front and the back. Okay, and on the cubes,
Top
top and bottom.
These 2 sides, and then right here.
Perfect.
Front and the back.
Okay. So that's 3 directions of cleavage. Now let's look at the angle between, say, the top and the front side. What would you say the angle is between the top and the front side?
It's a right angle.
Same thing on those cubes?
Mhm.
Okay, it's a right angle, right?
Right.
Okay. Now I want you guys to take a look at this one and see if you can find the 3 directions of cleavage on that one also.
So like these 2,
Okay?
these 2,
Perfect.
and the
Top,
these
bottom.
2. Yeah, top,
All right, so you found the top, bottom, front, back, and left and right sides. But how is this specimen different from these?
the shape is kind of different.
Angles?
Yeah. So the angle on this one is right angles. Is that right angles?
No.
No. But does it still have 3 directions of cleavage?
Yeah.
Okay, so we have 3 directions of cleavage in cubic, or 3 directions of cleavage at right angles or at 90 degrees. And on this one, we have 3 directions of cleavage not at 90 degrees. And this is actually called rhombohedral. Okay? But still 3 directions of cleavage. Again, with this specimen, if we were to take hammer and hit it and break it up, we would have lots and lots of little rhombohedra that would break off. 3 directions of cleavage, they would just look like that squashed box. Okay? So that's 3 directions of cleavage. We talked about 1, we talked about 2, and we talked about 3. When we see mineral specimens, lots of times mineral specimens with low amounts of cleavage, 1 direction, 2 directions, or 3 directions, they actually grow pretty readily. So we'll pick up a rock when we're out looking around at rocks, and we can find minerals that show that cleavage. When we get into the higher levels of cleavage, you have to go for the fancier specimens, and you don't find them very often because the conditions they need to grow under are not always found. So they're rarer and rarer and rarer. We have a couple examples here of higher amounts of cleavage. But before we look at that, I want to just look at the book a little bit for a second. So when you're in lab and you're practicing your determination of the physical properties, you're going to be using this book, and this is going to be a page you're going to love to have available to you. So let's take the pictures here, and let's see if we can match up a couple of these specimens to these pictures that are shown here. So this shows fracture, and it shows cleavage. Can you find specimens that match up to those pictures?
This one's that one.
Perfect. So
This would
that's
be like
fracture.
right here. Like part of that one or no?
What do you think? See how the ends are rough
Oh.
here?
Oh, so it's
Which one did we say had rough ends?
this one.
Great. Okay. Where do these go? Beautiful.
Right here.
Yeah. And what about our little flakes, our little 1 directions? Where do they go?
It'll go like right here.
Okay, so you can see how when you're in the lab and you're trying to identify cleavage for minerals, you can take the specimens and stick them right there on the book,
Right.
and that will help you out with identifying them. So this particular one, which is a mineral that's called fluorite, and the interesting thing about this for us is it's the state mineral of Illinois. You all knew that, right?
Yeah.
Just like cardinals are the state bird, fluorite is the state mineral. It comes in lots of different colors, and this is the perfect shape for it. And this one has 4 directions of cleavage. I'm going to challenge you. Can you find the 4 directions of cleavage for me? You might need to borrow a hand from across the table, too. Let's see if you can do it.
So that's 1, 2, 3, and 4? No?
What do you think? Are you looking for parallel sides?
Yeah, maybe. Yeah.
That's what you want to look for, is you want to try to put your fingers on the parallel sides, just like this. These 2 sides are parallel.
Am I looking for parallel sides?
Uh-huh.
Right? Yeah.
So is this side parallel to that side?
Yeah.
Okay.
Yeah.
Good.
And then there's these.
You
2.
got it.
And then. Yeah.
Those 2, and then the
Yeah.
other 2 that we don't have our fingers on. Okay? Lots of
Yeah.
fingers in there.
Okay.
Okay? So that's the 4 directions of cleavage. Even though it has 1, 2, 3, 4, 8 faces on it, it has 4 directions of cleavage. Okay? The last one that I want to show you really, really quickly, and this is very uncommon, is this one right here, which is called a dodecahedron. It has 12 sides, and it has 6 directions of cleavage. That particular crystal is a crystal of garnet. It probably took several million years for that crystal to grow under really perfect conditions, and it grows those beautiful 12 sides. We won't see things like that in lab, but they're really nice when we can see them.
Where do you find them?
You have to go for this particular one that came from New England, from some of the metamorphic belts in New England, so they are available, but they're rare.
Are they worth a lot?
Okay, so we talked about fracture and we talked about cleavage. What's the difference if you're looking at a mineral and you see fracture versus you see cleavage? What would you look for to tell if it had fracture or to tell if it had cleavage?
Fracture, all you have to do is like try peeling it off to see if it comes off.
Okay.
Random, uneven sides for fracture.
Uneven sides?
Yeah.
So not flat, right?
Yeah.
Okay. And for cleavage, what are you looking for?
They're more like smooth and the cuts are more even.
Okay. And you'll notice that the luster on all those cleavage faces is a very high luster. They're shiny,
Right.
whether they're metallic or not. Okay. That's cleavage and that's fracture. Questions about that? No? No? Okay. Nice job. Thanks for joining me. Bye, guys.
Bye.